Okay, next we're going to go to actual configuration of the client-based SSL VPN tunnel on the ASA. So what we're going to do is we're going to consider the test PCA to be our client, which has AnyConnect pre-installed already, and ASA feed to be our VPN gateway. We're going to follow up on those steps, and in the end, we're going to configure the VPN gateway. With a split tunnel, we're going to authenticate the test PCA using the local database of users on the ASA, and the split tunneling policy is going to be such that I'm going to send traffic in the tunnel only if it's destined to that 10.444/32. And on the ASA, I'm going to assign addresses to AnyConnect clients from the range of, let's say, 192.168, another private range, .1.0/24. So an IP from that range is going to get assigned to the PC, and the PC is going to assign that address on the virtual NIC card of the AnyConnect client. So we're going to use ASDM to begin with, because for the CCNA exam, as I stated, the focus is on the GUI if you get any simlets in there, but of course, as I stated, you need to get used also with the CLI ideally. I'm going to do what I've done in the IPsec section. We're going to run the wizard, and then we're going to copy the commands in Notepad. So I'm going to clean up whatever is extra not needed in there, and then I'm going to also walk you through the resulting configuration to map the configuration on those steps we have talked about so far. So we go under the Wizards tab, we say VPN Wizards, and then AnyConnect VPN Wizard. So we say next. Connection profile name, let's give it a name AnyConnect_users, for example. I have only one connection profile. On which interface will the AnyConnect VPN sessions be terminated? Is going to be on the inside interface in my case. So the VPN, all SSL VPN sessions are going to be terminated on this interface of the ASA, which in my case is the inside interface. Next. Now, what are the protocols? Because AnyConnect can support both IPsec and SSL VPN sessions, I'm going to use it only for SSL. So unclick IPsec. Then, because we use SSL, what is the certificate you want the ASA to use? And I'm going to say manage. We can use the built-in one because, technically speaking, we should be able to say next, which means the temporary built-in one. Or if I say back, I can say manage and generate a self-signed permanent certificate. Otherwise, we can from the GUI enroll, for example, with Entrust. It's built in the GUI to get a certificate from a trusted CA, which is Entrust. Or, of course, we can import a trusted certificate also via the add function in here. We're going to say add ASDM, let's say not ASDM trust point, is going to be SSL trust point _ self-signed. And I'm going to say add a new certificate because it's going to be self-signed. I'm going to have to generate a private public key pair. I can use an existing one. Ideally, you should generate a new one of type RSA is going to be key strength higher the better to 2048. Key pair name is going to be SSL RSA keys. Generate now. The private public key pair is sent. And then in this portion in here, we also say generate self-signed certificate. We can actually change in here the subject DN. This is going to be the identity of the SA. So remember what I said about a certificate? It's nothing else but the public key alongside with the identity information of the owner of the public-private key pair and signed by the CA. So this is the portion where we have configured the private-public key pair, and in here we configure the identity of the ASA, and then it's going to send those informations to itself, like as a CSR request, and sign them with a private key from the RSA private-public key pair. So in here in the subject DN, we can say select to do nothing else but change like what is the identity of the SA. I'm not going to put anything in there special for the moment. And then we say add certificate, send. Everyone has succeeded. Self-signed certificate is being available now. Okay. Now I'm going to choose, of course, to use that certificate for SSL VPN connections. Let's say next. Client images. As I said, you have to tell the SA, okay, what are the AnyConnect client images for which operating system, so the SA knows which systems can connect to the ASA VPN gateway via an AnyConnect session. And I'm going to put in here from Flash the Windows image, say OK. Then let's say next. Authentication method, how do you want to authenticate the remote access users? I'm going to use the local database, which is the default. I'm going to choose a new username. Let's say SSL user, SSL VPN user, with a password of Cisco. And we add it in the local database of users. We say next. Then what is the IP address assignment method for the AnyConnect clients? I don't have any. I'm going to use a local pool. I don't have any default pools configured. I'm going to say new for IPv4, not IPv6. Of course, we can assign both IPv4 and IPv6 addresses. In my case, it's going to be on IPv4. The name of the pool is going to be pool for AnyConnect. And as I said, it's going to be starting IP 192.168.1.1, ending 192.168.1.255, subnet mask session 4. Say OK. Do you want to assign, so when the ASA is going to assign an IP address from that pool to the clients, it can also, of course, assign to the client DNS domain, DNS information, WINS information, WIN server information, and domain name. And all of that information is going to get likewise installed on the client side on the AnyConnect NIC card. Of course, you would need this information if the remote access clients wouldn't need to access any kind of resources over the VPN tunnel via the fully qualified domain name. I'm not going to put anything in here in my case. I'm going to say next. There is no non-exempt in here. Next. And next and finish. Let's copy paste this in Notepad. I'm not going to paste it in from here. I'm going to paste it in from the CLI because I want to guide you through the configuration to the end resulting commands. So let's follow up on those steps. Of course, certificate is not being, it doesn't show up in here, the certificate step. But first step was to enable SSL VPN. We go on a web VPN, enable it on the inside interface. We specify what the image is, and we enable AnyConnect sessions, because without the AnyConnect enabled configuration, the ASA is going to allow only clientless SSL VPN sessions on the inside interface. This configuration is required in here. It's not a discussion for the CCNP. It's a CCNP topic, pretty much. that when the AnyConnect clients are going to connect, the ASA needs a way to know on which connection profile to attach those sessions. Because you're gonna have multiple connection profiles for different types of users, and based on the connection profile being connected to different pre-login settings are being configured. Like you may have one set of users to be authenticated locally on the ASA, and one set of users being authenticated remotely to a radio server. It means you're going to end up having in there two connection profiles. So the ASA needs to know on which connection profile did a VPN session land or connect to. And for the CCNA exam, this command allows what's going to happen. The ASA is going to publish in the portal all tunnel groups or connection profiles so that the client can choose on which one to connect. Of course, that's not a good thing in production networks in general, but just to make it work is going to be good enough. That was step number one. Then step number two, the authorization. So we put in there the pool to assign addresses to clients, and of course the split tunneling policy, which didn't show up in here probably. Let's configure it manually on the ASA. Because as I stated, I want to allow the client to send traffic in the tunnel only if it's destined to 10.444/32. So on ASA tree, we say access list, AnyConnect, split tunneling, and it's going to be permit to 10.444, and that's my split tunneling policy for this SSL VPN tunnel. Then we combine we put the authorization attributes under the group policy. Let's give it a better name. Let's say just AnyConnect users attributes. Of course, the first command is required to just create a group policy to begin with. The first command creates the group policy, and then we configure the attributes in there. This is used to restrict all connections landing on that connection profile, which is going to have this group policy attached, to be only of type SSL client, which means AnyConnect based sessions. And in here we're going to have to say something like address pool, this one, which is not configured yet, value address pools value that. And also the split tunneling policy, which is going to be split tunneling policy. It is going to be tunnel specified, but if it's going to be tunnel all, I want to tell the clients to send in traffic in the tunnel only as specified, not all traffic. And I got to tell it what exactly, which is going to be split tunneling, split tunnel, network list, value, and the ACL. Value and the access list. Of course, we could have defined it from the SDM as well. I'm going to show you where to find it. So first step was done, enable AnyConnect VPNs. Second step, configure the authorization, IP addressing, and split tunneling policy. Third step, configure the group policy, and bind in there the pool and the split tunneling policy. Next step is configure the tunnel group, the connection profile. Which is going to be named AnyConnect users type remote access. General attributes is going to be the default group policy attached. So with this command, what this means that once all VPN sessions connected to the tunnel group, once the tunnel is going to be up, I'm going to authorize those VPN sessions as configured in that group policy. The address pool can be configured as I stated under tunnel group. I put it in under the group policy. Authentication method is default local, so nothing to configure. And group alias AnyConnect users, because that's going to be this is going to be the name of the profile published in the web portal via this command. So when the users connect, they can choose on which connection profile to connect to, which is going to control how they get authenticated, and then once tunnel is up, how they get authorized via the group policy. This was the step where I've defined what certificate to be used for the SSL VPN tunnels. And of course, the last step was to configure the username in a local database, because I'm going to use local authentication, local database authentication for the SSL VPN sessions. So let's paste this in. Then configure the group policy. Any errors in there are because something has been pre-configured already, like the access list, and then the tunnel group. And there we go. Now looking at on the ASDM, let's say refresh before we connect. To see the resulting configuration, which would have been done through the GUI, as I've done it through the CLI, you go under configuration. Then you go under, it makes sense, out of remote access VPNs. I want to see the configuration of remote access VPNs. Then you go in here under network client access, which is going to be client-based remote access sessions, not under clientless. It's going to be for clientless SSL VPN sessions. So you go on a network. And then you have in here the AnyConnect connection profiles tab, where we have enabled AnyConnect sessions on that interface. And we have specified which certificate to be used. And we have configured our connection profile named AnyConnect users in there. So if you click on that, you say edit. You're going to see in there, of course, the name as it was configured, the alias, what the alias is. This is what is going to be published in the web portal. So when users connect, they can choose on which connection profile to connect to. Authentication method is AAA from the local database of users, and the group policy being attached. And SSL VPN is enabled. Pretty much that's the most important part on the connection profile. And of course, then we go to the group policy, under the group policy container, and we have our AnyConnect users group policy, say edit, which in there we have specified from which IP pool to assign addresses to clients. And then if you go to more options, we have restricted what kind of VPN tunnels can be successfully built based on this group policy, and it's only client-based SSL VPN sessions. And then under advanced, we have to see the split tunneling policy. So split tunneling, we have stated that I want to instruct, what is the policy? I want to instruct the AnyConnect users to send traffic in the VPN tunnel only as per the following configuration, which is going to mean send traffic in the tunnel only if it's destined to networks matched in that ACL, which is going to be in my case 10.4.4/32. Now on the client side, on the PC side, we fire up AnyConnect. We put in here the IP address of the VPN gateway 136.1.37.16 connect. Let's make sure we can ping that IP. We have IP connectivity with the VPN gateway, and we do. It pops up this message because the certificate of the VPN gateway is not trusted because it's self-signed. If we say details and subject, as you can see, the CN is ASHV was the default one, and issuer is ASHV, but I don't trust the issuer. I don't trust that CA because it's self-signed. So it pops up the message to say, do you accept that this is actually ASHV? And I say, yes, I accept. I know that's ASHV. If I would have used on the ASA a trusted certificate issued by a trusted CA, I would have not seen that message in there. At this point, what they do, what happened once I accepted the message, they went through those client hello, server hello messages. They have negotiated TLS, SSL versions, key management algorithms, encryption, hashing, everything in there. And then I got prompted to which tunnel group do you want to connect or connection profile. I have only one configured. And I'm going to authenticate using the username of SSL VPN user with a password of Cisco. It seems it's blocked. Let's restart a client. I have accidentally hit connect, say accept, and it should prompt me again for the username and password. So of course in a production network it's not going to be as slow as in here. It's going to be instantly connected and prompt me for username and password authentication. But in this case, because this is a VM, it's a bit slower. So I say accept. And username is going to be SSL VPN user with a password of Cisco. There you go, established. If you say now on this side, if you say ipconfig, on the Cisco AnyConnect NIC card, that's the Cisco AnyConnect NIC card, we have been assigned that address from the VPN gateway, as expected from the pool configured on the gateway. If we say route print, we should see now that the route print, we should see that the PC sends traffic in the VPN tunnel only if it's destined to 10.4.4.4. So as you can see here, this line says that if destination network is going to be 10.4.4.4/32, I'm going to route that traffic on this interface, which is going to be the AnyConnect NIC card, and nothing else gets routed in the VPN tunnel. Of course, we could likewise verify that around. We go to the AnyConnect client, we say advanced and VPN, and we go in the route details tab, and protected secure routes is 10.4.4.4/32. If we look on the ASA side and we say show VPN session database, detail AnyConnect, or we can just say AnyConnect. Let's keep it simple because it's a long discussion for the CCNP level. So what happened is this was my AnyConnect client which got connected, the public IP of the client. This is the assigned address by DSA to the client. This is the tunnel group where the client connected, and the group policy associated to that tunnel group, which was the authorization part of the tunnel. And we have those tunnels up and running, the SSL and the DTLS tunnels in there. Actually, that's the parent tunnel. It's not a discussion, but let's say we speak about that in the CCNP class, what a parent tunnel is and what everything else is. So to keep it simple, as you can see, what happened is one TLS tunnel has been established, one DTLS tunnel has been established, and also one AnyConnect parent tunnel. We speak about this in the CCNP class, what each of those tunnel does. And of course, if you go now and you telnet to router 4, it's not going to work as expected, because I forgot to do one step, right? So when the tunnel has been established, and it has been established successfully, now when PCA sends traffic in the tunnel destined to router 4, it sources that traffic with its AnyConnect design address. And the problem is that router 4 doesn't have route back to that destination. If you go on the ASA, ASA has installed a host route for that design address to the client. Show route. You got the host route in here, but it doesn't advertise that into EdgeRP. So let's go on ASA, go under the IGP, and redistribute those host routes. We say show run router. So before I redistribute those routes, let's make sure router 4 that doesn't have a route for that destination. It cannot know that destination. There we go. So going on SHV, router EdgeRP 50, we say redistribute static. Now router 4 should have an external EdgeRP route for that. There we go. It's a host route from ASA, which means now going back on the client, I should be able to connect to router 4. So the problem was not the SSL tunnel, but the routing. And if we say who, as you can see, connection shows to come from the AnyConnect address of the client, which confirms traffic was sent through the SSL VPN tunnel. Verification wise, of course, you can go also look in the ASDM under the monitoring tab. You're going to see again the same thing as with the show VPN session database detail AnyConnect. So monitoring VPN sessions, and you have one AnyConnect client and one SSL DTLS session. If you want to see the details, you have to look on this side, but you don't see anything at all because by default the filter is IPsec site to site. So let's change that filter to be AnyConnect client sessions, all sessions, and there we go. Of course, you can also filter, if you so choose to, by the username, because when you have multiple sessions established, you would want to look at the status of a specific session, not all of them. You say details, and we're seeing here pretty much the same thing as we saw in the GUI. In the CLI, this is going to be the parent AnyConnect tunnel. Next is going to be the SSL tunnel, and then the DTLS tunnel. So next is going to be the SSL, or actually it's a bit misleading because the technology is called SSL VPN, because this shows up as an SSL tunnel, but we negotiated TLS actually. So it doesn't mean that if it shows SSL tunnel, it doesn't mean that it's going to use SSL, not TLS. You have to look at the details of the session to see which protocol was negotiated, SSL or TLS in there. And of course then the DTLS tunnel, which runs over UDP.